find 1 divided by z square minus 3z plus 2 in these given regions. Right? So the first part is mod z strictly less than 1. Before starting with the solution, let's read this remark that 1 divided by 1 minus z equals to 1 minus z the power negative 1. We can write this as 1 minus z the power minus 1. And by using the binomial theorem, this is equal to 1 plus z square plus z cube up to so on. For mod z strictly less than 1, it is very important. We always use this expansion when mod of this z, that is the mod of this z, should be strictly less than 1. Right? Please keep this in mind. The first part is mod z strictly less than 1. We can write this function as, when taking the factors, this is z minus 1 into z minus 2. And then making the partial fractions. For that, just write here z minus 1 and here z minus 2. When considering this denominator, just hide this and put this equal to 0 and get the point z equal to 1 and then put this value over here. We get 1 divided by 1 minus 2, that is negative 1. Similarly, when considering this denominator, taking this to be equal to 0, we get z equal to 2 and hide this. Put this value over here, we get 1 divided by 2 minus 1, that is 1. And here the positive sign. So writing this further as 1 divided by z minus 2 minus 1 divided by z minus 1. Right? We need to use this condition, mod z strictly less than 1. So from this denominator, what should I take common? If I take minus 2 common from this, I will be getting 1 minus z divided by 2. And to expand this, we need mod of z by 2 to be strictly less than 1. Right? We are having the condition mod z strictly less than 1. If mod of z is strictly less than 1, then mod of z by 2 is also strictly less than 1. Yes? Z by 2 is half of z. So it is important to take negative 2 common from this denominator instead of z. And here if I take negative common, I get 1 minus z. So managing these negative sign, I get positive sign over here. Is it fine? Let's take minus 2 common from the denominator in the next step. And to expand this, we need mod of z to be strictly less than 1, which is already given to us. Right? Okay. So let's take negative 2 common from the denominator in the next step. So this is equal to 1 divided by minus 2 into 1 minus z by 2 plus 1 divided by 1 minus z. Let's take this bracket to the numerator and also taking 1 minus z to the numerator with power negative 1. So this is minus 1 divided by 2 into 1 minus z divided by 2 the power minus 1 plus 1 minus z the power negative 1. So this is equal to minus 1 by 2. Expanding this, we get 1 plus z divided by 2 plus z divided by 2 whole square up to so on. Up to 3 terms it is okay, right? Plus expanding this, 1 plus z square plus z cube up to so on. For mod z strictly less than 1 and mod of z by 2 strictly less than 1. This you have to write. So this is equal to, okay, if I multiply negative 1/2 inside, I get minus 1/2 in the first term, and also I'm having 1 over here. So 1 minus 1/2 is 1/2. And when multiplying this with the second term, we get minus z divided by 4 plus z. So we get plus 3z divided by 4. Similarly, when multiplying this with the third term, we get negative z square divided by 8. And here I am having z square. So we are getting plus 7z square divided by 8 and so on. So this is the required expansion for the region mod z strictly less than 1, right? So first part is done. Let's move on to the second part. That is when mod z strictly greater than 1 and strictly less than 2. After taking the partial fractions, we need to work on this. So from this part, we can write 1 divided by z mod to be strictly less than 1. And from the another part, we write z divided by 2 mod is strictly less than 1. Isn't it? So according to these two conditions, we have to work on further. I'm having z minus 2 in the denominator. Which is the better option? Should I take z common from the denominator or negative 2 common from the denominator? Which is the better option so that I can apply these conditions? So it is better to take negative 2 common from the denominator. So taking minus 2 common from the denominator, we get 1 minus z divided by 2. Minus, for the second term, I'm having 1 by z to be strictly less than 1. So it is better to take z common from the denominator so that I can get 1 minus 1 by z. I have to apply the mod of these two, right? From these conditions to apply the binomial theorem. Okay, let's take this brackets to the numerator. So minus 1 by 2 into 1 minus z divided by 2 inverse minus 1 by z into 1 minus 1 by z the power negative 1 or inverse. So this is equal to minus 1 half. Okay, expanding this binomially, we get 1 plus z divided by 2 plus z square divided by 4 plus z cube divided by 8 and so on. Right? Minus 1 divided by z into, expanding this, we get 1 plus 1 by z plus 1 by z square up to so on. You have to write with this that for mod of 1 by z strictly less than 1 and mod of z by 2 strictly less than 1. From the given conditions, you have to write this. Writing the first term as it is and multiplying 1 by z inside, we get minus 1 plus z square plus z cube so on. So this is the required expansion for this region, right? Let's move on to the third part now. If mod of z is strictly greater than 2, from this condition, we must write 2 divided by z, its mod is strictly less than 1. We have to use this. So this is equal to, I must take z common from this denominator. So this is 1 minus 2 divided by z so that I can apply this condition. Taking z outside of this, I get 1 minus 1 divided by z. Now for this, I need 1 by z mod strictly less than 1, which I can get from here. Mod of 2 by z strictly less than 1 means twice of mod of 1 by z strictly less than 1. If twice of this mod is strictly less than 1, then this implies obviously mod of 1 by z is also strictly less than 1. Yes, so we have got this condition for this. Okay, so from mod z greater than 2, we are getting this condition and this condition. So now let's take these brackets to the numerator. Expanding this is 1 plus 2 divided by z plus 2 divided by z whole square up to so on, minus 1 by z into 1 plus 1 by z plus 1 by z square up to so on. For mod of 2 divided by z strictly less than 1 and mod of 1 by z strictly less than 1, please remember this is very, very important to write. So this is equal to, this is 1 by z plus 2 divided by z square plus 4 divided by z cube so on, minus this is 1 by z minus 1 by z square up to so on. So these two cancelled out. 2 by z square minus 1 by z square gives 1 divided by z square. Similarly, third term I'm having minus 1 divided by z cube. 4 divided by z cube minus 1 divided by z cube gives 3 divided by z cube. Then 7 divided by z the power 4 and so on. Z the power minus 2 plus 3z the power minus 3 plus 7 into z the power minus 4, so on. Up to 3 terms it is okay. So this is a required expansion for the third region, that is this one. And now let's move on to the fourth part. This is very important. I'm having mod of z minus 1 to be strictly less than 1 and greater than 0. From this part we don't need anything. From this part we are having the condition mod of z minus 1 strictly less than 1. We have to use this condition. So because I need z minus 1, so can I write z minus 2 as z minus 1 minus 1 minus writing the second term as it is. For this condition, I must take negative sign outside from this bracket. So this is 1 minus z minus 1, right? Minus 1 divided by z minus 1. Let's take the denominator to the numerators with power negative 1. So now expanding this for mod of z minus 1 to be strictly less than 1. So this is negative 1 plus z minus 1 plus z minus 1 whole square up to so on. Minus, writing this as it is, z minus 1 the power minus 1. We don't have any condition for this to be as mod of z strictly less than 1. We are not having this condition, right? So there is no need to expand this. Just write this term as it is. So this is equal to, I'm writing this first, minus z minus 1 the power negative 1, and then this term minus 1 plus z minus 1 plus z minus 1 whole square up to so on. So this is a required expansion for this given region, right? So this is how we expand by using the given conditions, and we have to keep in mind that always we have to take something in the mod to be strictly less than 1, right? Then accordingly we use these conditions to expand further by using the binomial theorem. Okay, thank you. Stay blessed.